All right. So, hello and welcome everyone. I hope we are live right now. Please give me a thumbs up if you are ready to start. I hope I'm audible and visible to all of you. Right. So, welcome back. So, again, we are back again after a long time. Not a long time, it's kind of like 4 or 5 days, right? All right. So, a lot of things were going on, and there are some more things that has been coming up. Okay. Especially for the upcoming JEE Advance and the upcoming BITSAT examination. Okay. So, stay tuned for that particular examination. Okay. All right. So I hope I'm audible and let's start. Okay. So today we are going to basically again continue the same thing that we were discussing. We were going on revising the topics for different JEE Advance, right? And today our topic is going to be differential equation. Now in the previous session of JEE Advance discussion, I took the topic of area under the curve. And connecting to the area under the curve, I am taking the topic of differential equation, which is again very similar to the applications of integral. Okay. Which is very chapter of applications of integrals, right? So that's why I'm taking this particular chapter so as to continue keep the rhythm on. Okay. So if you have if you are new to this particular channel, I would request all of you to please subscribe to the particular channel. And if you want to prepare for your upcoming JEE Advanced examination, especially if you want to revise the content, if you want to keep on practicing the previous year question, then you are at the right place. Okay. So today we are going to revise the previous year question, especially for the chapter of differential equation. So I understand that you have already done your preparation for JEE Mains, and then you have already discussed the differential equation, right? So I think you have done the proper revision of that. So before coming to the end of this the last class, I discussed that we want to start our differential equations. So I think you have quite done the revisions on that. Okay. So before you start for this class, I will again request all of you to please go through your NCRT as well as your NCRT exemplar. Okay, please go through your NCRT as well as NCRT exemplar so as to, and also if you haven't prepared short notes, then please do prepare short notes. Okay, because this is going to be very, very beneficial, especially in solving the questions. Okay, all right. Is this part clear to all of you? Is this part clear? Right. So I'm assuming this part is clear. So, and if you feel like you are missing on some particular topic or any particular basic concepts, you can always watch my previous lectures. Okay. If you go to this channel, you can find all the live sessions under the live tab. Okay. Go to the live tabs, and you can also find the playlist also under the playlist section. Okay. Especially I've taken a lot of sessions, especially for the JEE Mains, and while I've discussed the basics part, and I've also prepared the previous year questions. Okay. So I hope that has been helpful to all of you. Okay. So with that particular note, let's get started. And today our idea is going to discuss on the topic of JEE Advance. Okay. So today I will be showing the questions, especially for the JEE Advance, and we are going to revise the topic as per the JEE Advance concepts only. So it is going to be a one shot, going to be revision plus previous year question solving. Okay. So let's get started. So today our goal is basically to be discussing the previous year question of JEE Advance of the chapter of differential equation. Now, why did I take differential equation? Because differential equation is one of the very important and high weighted chapter. Okay. If you look at the previous year question of JEE Advance, you can find out that there has been lot of questions, especially on the topic of differential equations. Okay. So considering and keeping that in mind, we will try to discuss all the important previous year question, and along with that, we're going to do a quick recap and how to solve the questions. Okay, and also we are also going to look how we should think and approach the question if in turn a different or a new type of question come up. Okay, so keeping all that in mind, let's get started. Along with that, we can practice both the MCQ, the multiple choice type question, the numerical type questions, and the previous year question of JEE Advanced is all the integer type question as well. All right. So keeping those things in mind, let's get started. So before we start, I want to have a quick recap. I want to quickly revise the main concepts of the chapter of differential equation. Okay. So if we look at the main important concepts of the differential equation chapter, then first and foremost thing that you can always come up is the question of order and degree, right? So if you look at, so I know that you have already done your orders and degree things. So let us quickly recap on that particular thing quickly. So if you look at any differential equation, and let us say I have a differential equation of the form of a0 d to the power n y by dx power n plus a1 a to the power n minus 1 y d to the power n minus 1 and so on up to an, and that particular thing is some other p of q of x. Okay, So if we have this kind of differential equation, if we have a differential equation of this form, if we have a differential equation of this particular form, then from this differential equation, two things are very, very important and crucial to know. First is, what is the order of this differential equation? So if you look at the differential equation, the highest derivative that occurs in y, because here what you have to understand is that y is a dependent variable and x is an independent variable. So since we are dealing with the calculus for your class 12, so we will be only talking about the one variable function. Okay. So keeping all those things in mind, so here the highest derivative of the y that occurs over here is basically n. So therefore the order is basically going to be n. Now, second thing that you have to look into this question is the degree, right? Now degree is very much of tricky thing. Okay, it might exist for a particular differential equation or may not exist also, right? But how will you find out a degree of a differential equation? That is interesting to know is that, for example, if you have a differential equation which is represented in the form of a polynomial expression, what do I mean by polynomial expression is that, now if you recall the polynomial, if you recall the basic polynomial that you have already studied in your junior classes, let us say I have a polynomial like f of x, which is defined as a0 plus a1x and so on up to an x to the power n, where all the powers of x occurs as an integer or a positive integer, right? So in that particular form, we call this form as the polynomial form, right? So whenever in place of x, if I have the derivative, of x in the polynomial expression only, in the polynomial form only, then I will call this kind of expression as a differential equation. And for that particular differential equation, the degree is defined as the highest power of the highest derivative. Okay, or I should write it highest order derivative, right? So keeping all these things in mind, I know that you are in a position to discuss or deal with the any questions of differential equation, right? Now, looking forward, what mostly you have to basically deal in this particular chapter is, after you're able to form the differential equation, the next thing that you're going to do is basically approach the solution of the differential equation. Okay, so the first step is basically formation, right? Now, I would like to tell you what is the importance of differential equation, right? So, if you look at any physical system, all form of physical systems can be represented in form of a differential equation. Now, why I'm saying so? Because everything in the nature is very rhythmic and it follows continuity nature as well as it does not follow continuity nature as well, right? But if I am assume in theoretical sense, if I'm able to assume the particular form of the physics in the differential form, or if I'm able to relate the rate of change of any particular quantity with respect to the unknown or with the known quantities, then that particular form of the equation that becomes a differential equation. Like a very simple example, if I take on, let us say in physics, let us say I am standing in a tower, okay, or a building of a height h, right? Of a building of height h, right? And if I am dropping a ball of mass m from a building of height h, then the ball will fall downward. That is our common intuition, right? But if we try to that, if we are basically, and again I'm telling that we are discussing only in frame of the reference frame of the Newtonian reference frame. Okay, so we are considering the inertial frame of reference, so therefore I will be able to apply the Newton's laws of motion over here, right? So let us say we are in the inertial frame of reference and I'm observing that the body is falling down, right? So when we are discussing about the kinematics of the body, we are not interested about the dynamics of the force of the body, right? But let us say I'm interested about the force of the body, then the first and foremost thing, since I'm dropping this body in a free space, right? That is basically if the space is filled with fluids or air, right? So if we look at this particular ball over here, the ball will have some finite mass, that is m, right? Now let us say the ball is very, very small and there will be a gravitational force of attraction, right? Let us that particular force will given as m into g. Okay, the gravitational mass into the gravitational acceleration, right? Similarly, once the ball is falling down, since it is falling in a fluid medium, therefore it will exert a drag over here, right? So if you look at the drag, so that particular drag, the drag will be also a force in the body, right? So there will be a drag force on the body also. So let us call the drag force as Fd, right? So, and interestingly, if you are very interested about fluid mechanics, then you will be able to draw the streamline also, right? So the air will be like this. So I'm considering the body is falling downwards, right? The body is falling downwards, the velocity of the body is there, there is the acceleration of the body, right? So the body is falling downwards and considering all these particular dynamics, and if I'm able to Now, if I'm able to write the equation of motion for this body, the equation of motion will be looking like m into g minus this drag force should be equal to mass into acceleration, and let us say the acceleration is ax, okay, in the downward direction. So, or let us call this az, right? So, let us call this az, right? Now, at any instant of time, let us call the position of the body with respect to any fixed reference point, or let us say the point where I'm standing is basically the origin, okay? The point where I am standing is basically the origin, and with respect to that, I am defining my coordinate as x in the downward or z in the downward direction. So z in the downward direction, and I am defining y in the right side of mine, right? So considering this particular coordinate system, then if I am saying that the body at any time t is having a distance from the origin by a distance of z. Let us say there is a z distance from the origin, right? So at any distance, at any time t, then I am able to write this particular equation of motion itself only as m into g minus the drag force is equals to mass into acceleration, and acceleration is basically second derivative of displacement. So consider the displacement is z, so I can write this as d2z by dt square, right? This is what the acceleration will look like, or the linear acceleration will look like, okay? So I'm considering only the force equation right now. So this is basically a simple differential equation that I am able to form. Now, once I am able to get the differential equation, our next intuition is basically to solve for the solution of the differential equation. Now, why I'm interested to solve for the differential equation? Because I want to analytically solve that what is the reference or what is the position of that particular body at any instant of time t, right? So now this thing that what I said is the analytical solution. Now, analytical solution might not exist for any equation or any particular physical solution, okay? It is very true that analytical solution doesn't exist for any of the physical situation. But what we are trying to do in theory is that we are trying to theoretically minimize such conditions that we are basically able to analytically get to the solution, right? So in order, once we are able to form the differential equation, then the solution of the differential equation will give me the analytical result. That is, what is the position of the body with respect to any time t, right? So I have this particular information. So if I am having the information about time, then at any time or putting the time information in this particular solution, then I will be able to get the position of the body at any given time t with respect to the reference point. I hope this particular thing is clear to all of you. Please do let me know if this is clear or not. Is this part clear to all of you? Right. So the solution will definitely yield me the result for the given result, that is z is equal to z of t, right? What is the position of the body with respect to time t? Right. So that is what the aim of the chapter is basically to do with. Once we are able to form the differential equation, which is consisting of the differential derivative terms in the unknown variable, which is for the known variables, and once solving for it, we'll get the relation between the unknown and the known variables. Right. Is this part clear? Right. Now we move to the next part, that is basically a solution. Right. Or we are more interested into the solution of the differential equation. Right. The solution of the differential equation, let us say, let us take any simple sample differential equation. Let us try to understand that the solution of the differential equation can be found out in which of the following ways, right? So the only following ways that you have to learn, especially for your class 12 level, are basically you have to solve only the first order differential equation. Okay, first order differential equation. So mostly in the chapter or any chapter you will solve about, or anywhere in class 11 and 12, whatever differential equation you're going to solve is basically going to be the first order and one first degree, right? And the degree should be equal to 1, okay? And the degree is also equal to 1. So you are basically going to solve these kinds of differential equation at this level, okay? Now, first and foremost thing is a very interesting and easy way of solution is basically by doing variable separable form, okay? By doing a variable separable form. Okay, so if I recall that, let us say I have a differential equation which is of the form, let us give a simple example. Let us say I have a differential equation of the form that is dy by dx is equal to some function of y. Let us call this e to the power y, right? Let us, for sake of example, I'm taking this particular example, right? Now, if you look at this particular form over here, the form is very simple that it gets separated out in the variables itself, right? So what I'm trying to do over here is that if I take the variables of y on the one particular side, that is dy by e to the power y is equal to dx, right? So if I'm able to represent the differential equation in this particular form, this is called as variable separable, because I'm able to separate the variables with the corresponding derivative term, right? So then if integrate both the sides, if I indefinitely integrate both the sides, then also I will get the solution for my given required differential equation, right? So solution on integrating will basically come out as, this is going to be equal to e to the power minus y by minus of 1 is equals to x plus some constant c, right? Now on solving this, I am able to represent my given form as e to the power minus x is equal to minus 6 plus c. Now for getting the constant value, there will be some initial condition or boundary condition that we called as a boundary condition or the initial value problem, right? So based on the initial condition, we'll get that particular information, that what is my given value of the constant. Now similarly, in equations or differential equation where you have multiple variables, or you have a differential equation of higher order, then in that case you will need one or more boundary condition to get to the values of the constant. Okay, so depending on the problem statement, we will have the required statement given the problem in order to find the analytical result for the given y, right? And if I don't have the boundary or the initial condition, then the analytical result will be called as the general result or the general solution of that particular differential equation, right? So here in this case, I'm solving the general solution. So it is going to be equal to, now in this case, I have to take log on both the sides. That is going to be minus of natural log of minus of x plus c, right? So that is going to be my solution over here, right? So the interesting thing over here is that once we are able to get the differential equation, we have to separate the variables with the corresponding derivative terms. And if we are able to do that, then we are easily going to integrate, and on integrating, we will get the solution of the differential equation, right? I hope this part is clear to all of you. Is this part clear? All right. Do let me know if this part is clear or not. If you have any questions, you can always let me know. Okay. And if you are watching the session after the live class is over, you can always put your question in the comment sections. Okay. I will try to answer your comments within like as soon as possible. Okay. And if you feel my teaching is particularly good for you and it is helping up you also, then you can always contact the given number in the description box. Okay. So on contacting the description box, you can get a chance to get a live one-to-one interaction. And if you want to get mentorship from me, especially for the upcoming JEE Advanced and Bitside examination, you can always contact my team and reach out me with the number given in the description box. All right, so with this, let's start. And next thing, then again, we will have lot of other forms. And with the question, we are also going to revise the particular form. Okay, so looking at the variable separable form and the second form, let us take some other form, that is basically, that is form of when we have a differential equation, which is of the type of, like let us say, now this is called a form of differential equation, which is reducible to variable separable. Okay, differential equation reducible to variable separable. So if we have, okay, I also have a form of a variable differential equation which is reducible to variable separable. Okay, so what is that form looking like? Let us say I have a form of equation that is dy by dx is equals to some function of ax plus by plus c, right? This kind of form, I can try to approach this kind of form by reducing it to the variable separable form. So how will I do that? For doing that, let us say I take this ax plus by plus c as some another variable z. Okay, let us say I assume it some other variable z. Now having this particular variable, if I differentiate z with respect to x, then this result is going to be a plus b times of dy by dx. So from here, what interesting thing like I wanted to do is that in spite of solving this differential equation in this particular form, which is not kind of a simple form, what I am not able to simply variable the separate out the variables, right? So what I'm doing, I'm trying to replace that particular that complex form into a simple form where I'm able to separate the variables easily, right? So in this case, then our dy by dx, in this case our dy by dx is going to be equal to dz by dx minus a whole divided by multiplied with 1 upon b, right? And then I will put this form over here, and then my differential equation will be of the form of dz by dx. Then the differential equation will be of form of dz by dx, which is equal to f of z, right? And now this particular form is simply of the form of variable separable form. Okay, so once we are able to get this particular form, we are easily able to get the solution of this particular form as well, right? Is this part clear to all of you? Is this part clear to all of you? Okay, so I'm going through a live chat. Please let me know if you have any questions. Always we just proceed. Okay, now there will be some other forms of the differential equation. That is basically what if instead of this particular form of differential equation, now I'm erasing this part over here. So I hope you have taken the screenshot. Okay, so if we have this kind now, what else form of differential equation we can have is that, let us say I have a differential equation which is given in the form of a fraction, as fraction as ax plus by plus c divided by capital Ax plus capital By plus capital C. Okay, if we have this kind of form of differential equation, then from here what I'm going to do is that, now in this kind of form also I have to again represent one kind of this particular numerator or any denominator in form of the other, and then I will try to represent that particular complex thing into one particular variable, and from there I will again reduce it back to the variable separable form. Okay, so what I'm going to do over here is that, now let us say here I have a condition that is the small a by capital A is equal to small b by capital B is equal to some constant k. Let us say this particular thing occurs. And if this is true, then I can represent this form, that is ax plus by, as k times of capital A x plus capital By plus some constant small c is divided by capital Ax plus capital By plus capital C over here, right? Which is basically equal to dy upon dx, right? Now, over here, if I put capital Ax plus capital By is equal to some another constant variable z, then in that case also I am able to get the form of the solution, that is dz by dx is some variable of z, right? So then also I am able to get the variable separate form over here. So please remember, if this particular form exists, then we have the solution as follows. Okay, is this part clear to all of you? Right. So once we are able to get these forms of the variable separable form, or the equation of the differential equation reducible to the variable separable, then the solution is very, very simple, right? Now next we have also the homogeneous forms, and homogeneous form is quite important for your upcoming exam also. Okay, and what is more important for the upcoming exam is the linear differential equation of the first order, or first order linear differential equation, right? And there are some other certain other forms of differential equation that is called the exact differential form. Okay, now whenever in form of a differential equation, if you see the exact differential present there, then the solution of the differential equation become much simpler. Is this part clear to all of you? Right. So we will look into the solution of the homogeneous form and the first order linear differential equation as we discuss on the questions. Okay. So let us try to solve the questions one on one. Okay. So very first question is on your screen. Okay. Now this question is taken from the JEE Advanced previous year paper. So if you look at a JEE Advanced previous year paper, you'll find the solution. You'll find the question there, right? Not the solution, obviously. So let us try to see how we try to approach this particular question. Okay. So let us quickly read through the question. The question is talking about that we have a function f of x, which is a continuous and differential function on the interval of positive real number, such that f of 1, such that I have the value at f of 1 is equals to 2, such that the function value at 1 is equals to 2. And it is also said that the limit when your variable t tends to another variable x, that is basically given as t to the power 10 into f of x minus x to the power 10 into f of t divided by t to the power 9 minus x to the power 9, this particular limit is equal to 1. Now, once we have this particular limit, let us try to apply some of the concepts of the limits, right? Now, if you are going to think of this, applying this question by solving it by using the L'Hopital rule, I have no issues, okay? But let us try how we can make this question much simpler also, okay? So, I'm going to also use the L'Hopital rule. Let us see. So, L'Hopital rule or LH rule, okay? So, if I use the LH rule over here, then my limit will tend as limit as t tends to x, this is going to be 10 times of t to the power 9 into f of x minus x to the power 10 into f dash of t divided by 9 times of t to the power 8 minus x to the power 9 over here, and that particular is equal to value is equal to 1. Okay, so now if we put t is equal to x, then I see that this is not by becoming a 0 by 0 form, and it is basically becoming a finite result, right? So that is basically given as 10 times of x into f of x minus x squared into f dash of x is equals to 9 over here. And if I try to simplify this relation, then I will have the differential equation format, that is basically f dash of x is equals to 10 times of f of x divided by x minus 9 by x square. Is this clear? Is this part clear to all of you? Now I will assume that f of x is equals to y. So on an assumption that f of x is equals to y, I will able to represent this particular form of differential equation as dy upon dx minus 10 upon x into y is equals to minus of 9 upon x square. Now this particular form of differential equation is basically a form of differential equation of the first order linear differential equation, right? So LDE stands for linear differential equation of the first order. And for that, the solution is very interesting. First and foremost thing that you find out is basically the integrating factor, which is basically equal to e to the power integration of minus 10 by x dx, right? Which is basically going to come out as, and the integrating factor is going to come out as 1 upon x to the power 10 over here. 1 upon x to the power 10 over here. The next thing that we will have over here, once we get the different integrating factor, the solution is very standard. That is y into integrating factor is equal to integration of integrating factor into this 9 up minus 9 upon x square dx, right? Then the solution will be y into 1 upon x to the power 10 is equals to integration of minus 9 upon x square into 1 upon x to the power 10 dx, and then on solving it, I'll get the recurrent solution as y by x to the power 10 is equals to 9 upon x to the power 11, and there will be one more 11 over here, and so 9 by 11 divided by 1 x to the power 11 plus some constant c. Now, if you look at the problem statement over here, it is said that f of 1 is equal to 2. So that is basically given the value. Okay. So that is basically given for getting the initial, the condition of the constant. Okay. So let us, on solving that condition, that is f of 1 is equal to 2, I'll get my constant value that will come out as, so if I just put it x equal to 1, y is equal to 2, so I will get c is equals to, so from that solution, I'll get c is equals to 13 by 11. I will get c is equal to 13 by 11. So therefore, the proper solution of the differential equation, therefore I can write it as, so I'm writing it over here is that, so y of x is equals to, or f of x is equals to 9 upon 11x plus 13 by 11 x to the power 10. Okay, I hope this is clear, right? So from this, for x greater than 0, the f of x is basically equal to 9 upon 11x plus 13 by 11 x to the power 10, which is basically going to be option number B. That is going to be the solution for the particular differential equation question. Okay. So if you look at the problem, it involves a problem from limits, and consisting of the limits, then it has been reduced to the first order differential equation form. And from that, once we're solving the first order differential form, the result is basically equals to the following result as follows over here, right? So we have the following value of the f of x as equals to 9 upon 11x plus 13 upon 11 x to the power 10. Is this part clear to all of you? Is this solution clear to all of you? Please let me know if this solution is clear or not. Is this part clear? Are you able to get the same answer? Okay. So I'm waiting for all of you for your answers. Please reply. If you have any question, please ask. Okay. Give time. I know this question might be a little bit tricky in the beginning, because looking at the problem, you must be thinking that this is a problem of a limits, right? And you have two variables on both the sides. So I was thinking that it might be a little bit troublesome, right? But once you're able to use the LH rule and you get to the solution of the finite value of the limit and equal it to 1, then that form of the limit will basically convert it into the form of a first order linear differential equation. Is this part clear to all of you? Hi Yash. How are you doing, Yash? Okay, so I guess you're all able to solve this question. Okay, so and your answer is also option number B. Yes, there are only 7 members in live. You are correct. Yes. What is your answer? Yes. Yes. What is your answer? Are you also getting option number B? Okay, so I think you have done it correctly. Okay, if you have any question, you can always keep me updated. Okay, so I guess the solution is clear. I guess the solution is clear now. Okay, so let us move to the next problem then. Yes, we are teaching for the JEE Advance. Okay, the upcoming JEE Advance examination is there, right? In the month of May. Okay, no issue. If you are a NEET aspirant, also you can stay in this particular channel because there is also the classes for chemistry and physics for NEET also. Okay, if you look at the channel, you will find the topics for chemistry and physics also in the live section. Okay, you can always stay tuned for the chemistry and physics also. Okay, yes. All right. So let's move to the next problem over here. The next problem we have with us is again a question from the differential equation, right? All right, very good, yes. Okay, keep on doing it. And if you're interested in maths, you can also stay in this particular session as well. All right. So we have a function which is given as within the domain 1 to infinity and goes to the codomain, that is real number, and it is said it is a differential function. Okay, it is a differentiable function. It is a differential function with the given condition, that is f of 1 is equals to 1 upon 3. F of 1 is equals to 1 upon 3, and also said that 3 times of integration, definite integration 1 to x f of t dt is equals to x into f of x minus x cube by 3, right? We have this particular form of a integral equation. So from this integral equation, now in order to find out that what is the integral solution over here, what I can do is that, yes, okay, thank you, yes, that's good. Anyways, so keep on focusing on this question. So if we try to get that from this, okay, thank you, yes, yeah, we know that we are already 1K. All right, so we are a family of 1000 members now. Okay, all right. So looking at this integral equation over here, now if I try to differentiate this integral equation, what I will get is that if I integrate or if I differentiate first of all, so let us differentiate this integral equation. Now since this function is a differential function, I can differentiate this integral equation and the result will be f 3 times of f of x into 1 minus 0 is equals to x into f dash of x plus f of x minus 3x square by 3, right? This is what we will have if we differentiate both the sides. Is this clear to all of you? Now once we differentiate both the side, what I'm going to get is that we get a differential equation form. We get a differential equation form, which is basically again similar to the previous question. Yes, we have physics teacher also. Okay. Yes, I keep on telling physics also in along with maths, but mostly I will focus on maths, okay? Because we have different teacher for physics also in this channel only. Okay. And if you want to get physics one-to-one interaction also, you can always contact the number in that given the description box, okay? If you want to take mentorship on physics questions for your NEET examination, you can always get the mentorship there. All right. You can always watch the live content that has been taken on physics also. All right. So then we will have this form as 3 times of f of x is equals to x into f dash of x plus f of x minus x square. Now which I can now I if I represent f of x equal to y. Yeah, hi Indonesia. All right. So if I take f of x equal to y, then this particular form will become, yeah, there is no need to laugh on this. Okay. If 5 people are watching, that is also good, right? Not all people will go to IIT, right? That's the thing is there. Because IIT also has limited seat for general people, especially. Yeah, yes. Let me know if you will do. I will subscribe. Yes. We have already done those contents of physics. Okay, and don't worry, we will come up. We'll come up with the contents on physics for your NEET examination. Okay, definitely stay tuned for the channel. Okay, please subscribe the channel and then keep on the hit the bell icon so that you don't miss out any upcoming notification on the contents that is occurring there. Okay. There is nothing like that you have to subscribe or not. Okay, see, if you subscribe, you don't have to pay any price also, right? It is just for free. Okay, yes, if you subscribe the channel, it is just showing a point of a pay of respect, that is it. Okay, anyways, it's your choice if you want to subscribe or not, that is totally your choice. right? Yes, yes. Don't worry on in that. There's those people. Okay, there are a lot of spammers also in the live chat. Anyways, so looking over here, let us focus over here. So this is going to be for the form that is 2 times of y is equals to x into dy by dx minus x squared. And then if I try to reduce it, then this will be basically dy by dx, and what I'm doing, I'm dividing by x on both the sides. So dy by dx minus x is equals to y upon x, which I can write also as dy by dx minus minus y upon x is equal to x, right? Okay, is this clear to all of you? All right. So once we are able to reduce this particular form from the integral equation to the differential equation of this form, then the result is very, very simple. It is basically a first order linear differential equation, and the solution will be basically given out as, first of all, let us find the integrating factor, which is basically e to the power integration of minus of 1 by x dx, which is basically equals to e to the power minus natural log of x, that is basically equal to 1 upon x, right? Then the solution is basically y into 1 upon x is equals to integration of x into 1 upon x dx, and which will basically give the result as y upon x is equals to some x plus c, right? And for getting the value of the constant, we already have the initial condition, right? So y is equal to x square plus cx, and if we look at the condition over here, f of 1 is equal to 1 upon 3. So f of 1, that is y is equal to 1 upon 3 at x equals to 1. So putting x equals to 1, y is equal to 1 upon 3 is equals to 1 plus c, and therefore from here I will get c is equal to, therefore from here I will get c is equal to minus of 2 upon 3, minus of 2 upon 3. All right. Hi Harshit, how are you doing? Yeah, nothing like that. No one will decide. Okay. See Harshit, you are not an IITian. Okay. I have already cleared IIT. Okay. And I have received the silver medal as well. So calling noob and all those things is totally your point of view. Okay. I have nothing to look into it. Okay. Anyways, there will be a lot of spammers. Okay, don't worry. But I respect it. Okay, you are watching it. You are increasing my watch time. Thank you. Thank you, Harshit. Thank you, Indonesia, for increasing my watch time. Offline coaching is better than online. Indonesia, but at the same point, online is better. Okay, okay, fine. So if you are someone who is watching this session, okay, and you are following it, please keep on updated. Okay. Yeah, I am from IIT Kharagpur. If you can find out the description, okay, please look at the video title. The video title mention everything. Okay, and in the description box also everything is mentioned about me. Anyways, so so then from here, if I get the value of the constant c, that is minus of 2 by 3, from that I will get the solution. Okay, now we have to find out that what is the value of the functional expression at f of e, right? So at x equals to e, what is the solution? And that if I put from this result, that we have over here, let me write the result over here, which is basically x square minus 2 by 3 times of x. And if I put x equals to e, then e square minus 2 by 3e. Okay, so e square minus 2, sorry, e square minus 4. Actually, I think, yeah. So that is a mistake over here, is that I forget one sign. Okay, uh, just let me recheck. Okay, so there is a mistake. I forget one 2 over here. Okay, because if you look over here, this 3 minus of 1, that is basically 2. Okay, so there will be a 2 over here, which will make this differential form as 2 by x, right? This is going to be 2 over here. So similarly, on solving, we'll get to the solution of the constant value also will come out as 1 upon 3. Okay, then the constant will come out as 1 upon 3. Okay, so the constant will come out as 1 upon 3. And with this, if we try to put it over here, so actually the solution will be looking like, okay, and there is one more x squared term that is there. Okay, so we will have it is 2, sorry. So since there is a 2 over here, let me clear it off and let me do it again. So there is a mistake over there. So if we recheck the calculation again, then from here it will be 2 over here, and that will make this integrating factor as 1 upon x square, which the solution will be a y into 1 upon x square is equals to x into 1 upon x square integration dx, and that will come out as x square, and that will come out as natural log of x, and then plus some constant, and then from there I can write y is equal to x square into natural log of x plus some constant c. Okay, now from this I'll get the value of, if I put x equals to 1, y is equal to, so x equals to 1 or y is equal to 1 upon 3, and from there I will get the value of c coming out as 1 upon 3, right? So the c will come out as 1 upon 3, and from this I'll be able to find out what is the value of x equals to e. That will basically going to be equal to e square into natural log of e plus 1 upon 3, and that is going to be equal to, so if I solve it, so natural log of e is basically 1, so that is going to be equal to 1 plus 1 by 3, that is going to be 4 by 3 into e square. So with this we'll have the value of the function at x equals to e is equals to 4 by 3 e square. Is this part clear to all of you? Is this part clear? Right. So please recheck your calculation. Okay. So with this you will have the given solution as 4 by 3 e square, which is basically going to be option number C. That is going to be the correct answer over here. I hope you also getting the same answer. Option number C is the correct answer. Okay. Are you all getting the same answer? Do let me know if you are getting the same answer. Okay. The next question we have is a very interesting problem. Okay. Is this clear to all of you? Is this part clear to all of you? Right. So if you have any question, please put that up. Okay. Okay. So is this part clear? All right. So let's move to the next problem. The next problem we have is a very interesting problem. If we look over here, is that 8 times of root x multiplied with root of 9 plus another root x dy is given equals to 1 upon square root of 4 plus square root of 9 plus square root of x, right? If you look at the following result, it is as follows over here, right? Okay. Now looking at the problem, it is also said the following condition, that is y of 0 is basically given as root under 7, right? So once we have this particular information, let us try to see how we approach the solution over here, right? Now this problem is very interesting. I also love this problem very much. The thing is that it is not very simple in terms that you will not get the result very easily, right? But interestingly, if you are able to, so there is one dx term over here, okay? Don't forget. So what I'm going to do is that first of all, let us try to represent this particular form in the differential equation form, that is dy by dx is equals to, so that will be equals to 1 upon 8 root x into square root of 9 plus square root of x into 1 upon square root of 4 plus square root of 9 plus square root of x over here, right? As follows. Now let me keep the, now this is a simple form of variable separable form. So therefore, let us keep the y on this side and x on this side. And then if I try to integrate on both this side indefinitely, then I will get the solution, right? But the integration is quite challenging over here. So how will you try to proceed with the integration is that, now if you are very new to this particular kind of integration problem, then it might be little bit difficult at the beginning, right? But if you are very much interested in terms that you are able to manipulate the answer quickly, then the result is, what if you take this particular form as some variable t, then interestingly what you will find out is that, so if I assume this particular form this particular form, that is square root of 4 plus square root of 9 plus square root of x as some variable t, and if I differentiate both these sides, what I will get is that I'll get it as 1 upon 1 upon. So if I look at the differentiation over here, so what will I get over here is that, yes, so the result is going to be, so if I have like, if I have 1 upon square root of x, and if I differentiate this is going to be, the differentiation of this is going to be equal to minus of 1 by 2 into e to the power minus of 1 by 2 minus 1, right? Right. And so what I'm doing, I'm not taking 1 upon that. So I'm taking the x to the power 1 by 2 as taking differentiate out. So that is going to be equal to 1 by 2 times the square root of x, right? So if I apply the same over here, and then by chain rule I can differentiate it. So by chain rule, you will find out this is result is going to be 2 times of 1 by 2 times the square root of 4 plus square root of 9 plus square root of x, right? Now, with that, you will have to apply the chain rule, then multiply with, now my differentiation of 4 is going to be 0 into square root 1 upon 2 times of square root of 9 plus square root of x multiplied with, again, now in differentiation 9 is going to be 0, again 1 upon 2 times of x, and then you will have it as dx, which is basically equal to dt, right? So interestingly, what you are able to find out is that now if you club these two and this 2, it is going to be 8 times of root x, and then this particular form is also coming out. So what is more interesting is that now once you assume this particular thing as t, the result is going to be very simple in terms that integration of dy is basically similar simple to as integration of dt. Simply just assuming this as t, it comes out simply as integration of dt, right? So it is going to be like, there will be t over here, yes. So there will be t over here. Um, just let me recheck. So this particular entire form, is basically dt, right? This entire form is basically going to be dt, and yes, yeah, correct. So this is going to be dt, right? Integration of dt, and therefore on solution we'll have y is equal to t, and t is basically square root of 4 plus square root of 9 plus square root of x plus some constant c. Now, if we look at y x equal to 0, y is basically given as 7. Sorry, root 7, right? Root 7. So from this, if you put x equal to 0, the y value will come out as root 7. So therefore, your c is basically equal to 0. So on putting y is equal to 256, for x equal to 256, the y value will definitely come out as, tune and come out as equals to 4 plus square root of 4 plus 5, which is basically equal to 9. Square root of 3, that is basically equal to square root of 9, that is basically equal to 3, right? So with this, you will have the answer to this particular problem as option number B, which is going to be equal to 3. Is this part clear to all of you? Is this part clear? Right? Is this clear to all of you? Okay, so this question looks difficult in the beginning, but if you're able to take the proper term as the given variable, then the result is very, very simple. Okay, you just have to assume this particular term as t, and then it will simply count the entire term will simply count as dt, right? So that is the advantage of this kinds of problems. Okay, so this problem might look very difficult in the beginning, but it is very simple, straightforward problem. Is this part clear to all of you? If something is not clear, you can always put that up in the live chat. Okay, and if you're watching the session after the live class is over, you can question that particular problem in the comment section as well. Okay, I'll be happy to answer your questions. So I hope this is clear. I hope this part is clear to all of you. Right. So let's move to the next problem then. Now again, we have another very interesting problem, which is basically of the form of first order linear differential form. Right. So if we look at the problem, it is said that y is equal to f of x is a solution of the differential equation, which is mentioned as dy by dx plus x into y by x square minus 1 is equals to x to the power 4 plus 2x divided by square root of 1 minus x square, right? And it is said that the solution is lying in the interval -1 to 1 with the condition that is f of 0 is equal to 0, with the condition that is f of 0 is equals to 0, right? Okay, so if you look at the form of the differential equation, it is the form of the differential equation of the first order linear differential form, right? First order linear differential equation. So first order linear differential equation is very simple to solve. So try to find out the integrating factor over here. Please try to solve this question. Please try to solve this question. Okay, I'm going to a live chat. Yes, Neeraj, C is correct. Are you sure? Let me check. Are you sure or not? No, Neeraj. No, Neeraj. C is not the correct answer for this question. Please take your time, Neeraj. Or are you talking about the last question? No. Right. So please try to solve it again. C is not the correct answer, Neeraj. Okay. So let us try to solve it. Okay, first of all. So looking at the differential equation of the first order linear differential form, first and foremost thing that I will do is getting out the integrating factor. So if I try to get out the integrating factor, that is basically e to the power integration of x by x square minus 1 dx, right? Now the integration of this can be easily done by taking this term as the t or by substituting this, okay? So this if I substitute as t, then this is going to be, let us try to make it to the form of e to the power 1 by 2 into 2x divided by x square minus 1 integration of that. And if I do it, then if I assume t x square minus 1 as t, then 2x dx is going to be dt, right? So that is basically e to the power 1 by 2 integration of dt upon t, which is basically going to be e to the power 1 upon 2 natural log t, and that is going to come out as square root of t, and t is basically assumed as x square minus 1. So that is result is going to be square root of x square minus 1. So our integrating factor is going to come out as square root of x square minus 1. So the integrating factor is square root of x square minus 1. Are you all getting the same integrating factor? Right. So once we have the integrating factor, the solution is y into integrating factor, that is square root of x square minus 1 is equals to integration of x to the power 4 plus 2x divided by square root of 1 minus x. Okay, now interesting over here is that now since our solution exists or x values lying only between -1 to 1, so the result over here should be integrating factor should be taken as 1 minus x. Okay, now why I'm doing that? Because this result should give me natural log of mod of t, right? Natural log of mod of t. Now to make this result satisfying this particular region, that is -1 to 1, I should take the region that is 1 minus x square. Okay, so therefore this integrating factor should be come out as 1 minus x square. Okay, so then multiplying the integrating factor over here, this particular result is going to simply cancel out, and then therefore we'll have the simple result as x to the power 5 by 5 plus x square plus some constant c. So our result, and if we try to solve for the constant c with the given result that f of 0 is 0, so I will get the value of the constant. So f of 0 is 0, so I'll get the value of the constant as equal to 0 only. So I'll get the value of the constant as 0. So therefore the result of the differential equation, that is f of x, is equals to x to the power 5 by 5 plus x square divided by square root of 1 minus x square, which can also be written as x to the power 5 by 5 times square root of 1 minus x square plus x square by square root of 1 minus x square, right? Now the next part of the solution question is basically we have to integrate this particular function f of x dx from minus of root 3 by 2 to plus of root 3 by 2. Now if you look at this particular limit over here, we have a limit which is very symmetric, right? So for symmetric limit for odd function, this is an odd function, right? So for symmetric limit of odd function, this result will turn out to be 0 on integrating from -a to +a. this integration will turn out to be 0, since it's an odd function. But this is an even function, so the result is going to be 2 times of integration 0 to root 3 by 2 x square by square root of 1 minus x square dx, right? Now, in order to solve this kind of problem, I'll take help of simple trigonometry. Okay. Also, you can solve this question by taking it as x square minus 1 plus 1 by square root of 1 minus x square, right? Now, what I will do over here is that I will take this and I will write it as follows, as minus of 1 upon x square square root of that plus 1 upon square root of 1 minus x square, and that will result in the integration from 0 to root 3 by 2 and 2 times of it dx, right? Now, if I solve this integration, which is very simple to solve out, the result is going to come out as, so the first integration result is very simple. It is going to be a by x by 2 square root of 1 minus, so that is going to be come out as x by 2 square root of 1 minus x square plus half of, because that is basically a square by 2, a square by 2, that is half of that, so that is going to be sine inverse of x over here, and then this result is going to be simply sine inverse. This result is also going to be equal to simply sine inverse of x, and on putting the limits, it will turn out as, the integration will turn out as, come out as pi by 3 minus root 3 by 2, root 3 by 4, sorry. So pi by 3 root 3 by 4. So therefore, I will have the answer this particular problem as option number B, which is basically pi by 3 minus root 3 by 4. Is this part clear to all of you? So option B is going to be the correct answer. Are you also getting the same as option number B? Is this part clear? Yes, Neeraj, please correct it. Okay. Option B is going to be the correct answer. Option B is going to be the correct answer, Neeraj. Okay. I hope this part is clear to all of you. Right? Is this part clear to all of you? Do let me know if you have any questions. If you still feel you are in confusion, you can always put that confusion or your questions in the comments box, okay, or the live chat as well. I will try to answer all your questions. And if you want preparation for your chemistry as well as physics, don't forget to subscribe to the particular channel, because we're also discussing the chemistry and physics portion for the upcoming JEE Advanced and the NEET examination. Okay. So please subscribe to the channel and hit the bell icon to never miss out any upcoming notification of the content that has been discussed. Okay. Right? Is this clear to all of you? So option B is going to be the correct answer. Okay. So once after getting the solution of the differential equation, you have to integrate it. Hi Ayush Verma. See, for getting an approach to these kinds of questions or JEE Advanced kinds of questions, what you have to do is basically have a good practice. If you look at this problem over here, first of all, looking at the problem, it is very simple to figure out that this problem is basically the form of first order linear differential equation. Let me tell you how will you figure out that. If we have in a differential equation the form that is dy by dx plus some function of x, that is p of x, multiplied with y is equals to some another function of x, but no value, no y is present over here, then this kind of differential equation is basically a differential equation of first order linear differential form, right? So on solving this, we'll get the solution. Now the most tricky part over here is basically to get this integration or the definite integration, right? For solving the definite integration, what I did over here is that I get this kind of result. Now this kind of result or approximation that I'm doing over here, that is putting the x square plus 1 minus 1, this will come only with practice. Once you practice a lot of questions, these kinds of technique will come out, develop very easily. But if you're still having doubt, you can always try to avoid these kinds of tricks. What you can also do over here is that you can put over here, x equals to sine theta. If you put x equal to sine theta, this 1 upon square root of 1 upon x square will turn out as cos theta. Right? And then it will be sine square theta. And you know that if you take cos theta as t, then sine theta will become d theta, right? Or dt, whatever term you are assuming, right? So that can also be solved by using the integration by substitution method also. Okay, so this will come only with practice. Okay, the more you practice, the more better you're going to become. Is this clear, Ayush Verma? Is this clear, Ayush? Okay. And if you still have any questions, any further question, you can always get one-to-one mentorship from me. Okay. Don't miss out on that particular opportunity. Okay. You can always contact me in the given number that is present in the description box. Please go to the description box of this particular video and you can find the contact number over there. Okay. Please contact me on that particular number, and if you have any questions, I can help you to clear that. All right. Okay, Ayush. That's interesting to hear. Okay. So keep the practice. Keep on the practice, and if you have cleared the JEE mains, then I think you have already done a lot of practice. Okay, what you do is basically keep on practicing the hard type questions, okay, or the question which is not very standard form, okay, or the question which do not give the answer in one step. Okay, kind of you have to apply your brain. In JEE Advanced, what will happen is that the question will come up with multiple chapters, or different chapters will be coupled up together. Okay, so that is what you have to encounter and you have to discuss that. Okay, and we are taking the live sessions just basically for that purpose only. So please stay tuned for this every live sessions, and in that way only we are going to cap up or cope up with these particular concepts. Okay, so difficult concept won't be any more difficult. Is this clear, Ayush? So I hope you will take the best use of that. Is that okay, Ayush? Great. So let's move to the next problem then. The next problem is a question from your application of derivative power. If you look at this problem over here, the problem is saying that the curve is passing through a point. So let us assume first of all the curve as y is equal to c. Okay, so y is equal to c be the curve over here, right? Now it is said that the curve passes through the point 1 comma pi by 6. Therefore, y is equal to pi by 6 is equal to f of 1. So I get one condition from here. Now it is said that the slope of the curve at each point dy by dx, that is a slope at any point x comma y, is basically given as y by x plus secant of y by x, right? Now this kind of form is called as a homogeneous form. So what will I do is that I will assume this y by x to some variable v, right? Now I can write y is equal to v times of x, and then I will able to write dy by dx is equal to v plus x times of dv by dx. Is this clear? Right. Now, once we have this form, let us replace it over here. So this will become v plus x times of dv by dx is equals to v plus secant of v over here. Now this v and v get cancelled out from both the sides, and now this particular differential equation is basically a differential equation of variable separable form. Right. So this will basically become equal to dv by dx is equals to sec of v, and let us keep the variable separable form over here. So from this, if I take this on this particular side, it is going to be cos of v dv is equals to dx by x. And then let us integrate both the sides to get the result as follows. That is sine v is equals to natural log of x plus c. Now our result should be in y and x. So therefore I should take it back, and therefore it will be written as sine of y by x is equals to natural log of x plus c. Now I have one condition, that is f of 1 is equals to pi by 6, that is x equal to 1, y is equal to pi by 6. So which will yield me the result as, so sine pi by 6 is basically half, that is half is equals to c. So from here I will get the value of the constant c is basically equal to half. So once we have this result, then the solution is basically like from of y sine of y by x is equals to natural log of x plus half, right? Which I can combine and write it as natural log of x into e to the power half over here, right? So if we have this result, then it is saying that what is the equation of the curve. So the equation of curve is very simple. Sine of y by x is equals to natural log of x plus half. So sine of y by x is equal to natural log of x plus half. So that is basically option number A from this solution. Okay. Is this part clear to all of you? Is this part clear? Yes, Ayush, I can explain, but which form are you talking about? Which three form again? See, Ayush, this is a live session, okay? And the advantage is that each session will be all recorded in the form of YouTube sessions, okay? So if you feel you have any questions, you can always rewind the session and go back and watch that content, okay? But still, if you have any question, you can always put that up. I will take it up. I will take it and I will explain that concept. Okay, please explain which three forms are you talking about? Are you talking about these initial forms of differential equation solution, that is a variable separable and then homogeneous form or the linear differential form? Are you talking about that? Yes, Ayush. Are you talking about that? Linear and homogeneous one. Yes. So linear and homogeneous, see, linear form and homogeneous. So if I quickly recap, I will try to explain it over here. So what is basically homogeneous is you have to understand over here is that now if you have any differential equation which is a form that is given as dy upon dx is basically equals to or what if I have a form of differential equation that is basically given as f of x comma y divided by g of x comma y, right? Now if I am able to approach this particular differential equation as f of y by x by g of y by x, I will call this form as equal to some other function capital F of y by x. Whenever I have this kind of form of y by x, I will call it homogeneous if and only if it satisfies this particular quantity. That is, if I put in place of x as lambda x and in place of y as lambda y, then it should come out as lambda to the power n f of x comma y for a particular form to be an homogeneous form. This is called as homogeneous. Okay, this should come out for be an homogeneous form. This should come out to for a function to be an homogeneous. Okay, is this part clear? So whenever we have a homogeneous form, this should satisfy. So over here, if I put in place of y as lambda y and in place of x as lambda x, then it's again come out as the same expression itself, or lambda will come out, right? So in that form, what I have to do is that I will have to assume this y upon x as some variable v. I have to assume this y upon x as some variable v, and then I will approach the solution as y is equal to v into x, and then if I differentiate both these sides, this is going to be dy by dx is equals to v plus x times of dv by dx. And now instead of solving for dy by dx, I will solve for dv by dx. Okay, so that is the only difference that you have to observe over here. So we will try to resubstitute back, and yes, exactly, that is correct. The lambda will cancel out. Okay, the lambda will cancel out, or if you are able to take the common of the lambda, okay, the lambda will also be taken out as common. Okay, so then this particular form will be a homogeneous form, right? And then the solution we are going to look in terms is that we will form the differential equation in dv by dx, and that will come out as a variable separar form. And from that variable separar form, I will solve for the v, and then I will reduce it back to the form of y. Okay, is this part clear? So once we get v, we can get back to the y by x from there, right? So that is the solution. Is this part clear? Yes, Ayush, is this part clear? Do let me know if this part is clear or not. Okay, Ayush. Right. Okay, wonderful. Wonderful, Ayush. Okay. If you still have any questions, you can always put that in the comment section. Okay. Now, please try to solve more and more questions. If you solve more and more questions, you will get these problems. Okay. This is a very, very simple form. Variable several form or homogeneous form, that is, if I have a differential form as follows, that is, if I have dy by dx is something as a times of x plus b times of y plus c divided by, or let us say a1, b1 and c1, and let us say a2x plus b2y plus c2 over here. Now, and more interestingly, if you observe, that is a1 by a2 should not be equal to b1 by b2, then I can try to reduce this particular form of the differential equation in a homogeneous form by putting in place of x, if I put x equals to capital X plus some h, and then in place of y, I'll put capital Y plus a k, right? And if I do this such that I will try to cancel out these constants, okay? I'll try to make the constant, that is a1 h plus b1 k plus c1 should be equal to 0. That is my first equation. And my second equation is that a2h plus b2k plus c2 should be equal to 0. So from these two equations, we'll solve it and we'll get the value of h and k. We'll get the value of h and k, and solving for h and k, I will put that back in this particular equation, and then it will be a form of where I'm able to get the format basically of some function of y by x, right? So that will basically get reduced to the homogeneous form. Is this part clear? All right. Is this part clear to all of you? All right. So with this, we wrap up for this video session for the discussion on the differential equation for JEE Advanced, right? Now I have certain questions left up for your homework. Okay. Now please take this question as a homework. Please take a screenshot and try to solve this question. Okay. Please take a screenshot and try to solve this question. There is a next problem over here as follows. Now this is a simple problem that I have solved already. So if you look at the solutions of the class problem that I have done today, you will feel that these problems are very similar to this question that I have already solved, right? So if you see, the question pattern is kind of very similar to the form of differential equation in terms of an integral equation, right? So that is very, very simple. So if you know the concept, you will be able to solve it very easily. Okay. So please try to solve these questions and let me know the answers in the comment section. Okay. After the class is over, please try to solve these questions and let me know the answer you are getting in the comments. Okay. So this is your homework problem. This is your homework problem and this is also your homework problem. So there are two homework problems, the homework problem number 1 and homework problem number 2. Okay. The results and the homework solution you will get it in the comments also. Okay. So please try to solve these two questions and let me know the answer you're getting. Okay. So homework problem number 1 and number 2. All right. Please take a screenshot and solve it and upload in the comment section. So with this, I would like to wrap up for this today's session of differential equation, and that will be the end from my part on differential equation take. Okay. We'll take up more questions or JEE Advanced in the upcoming sessions of definite integrals. Okay. So the next session we are going to have it on the topic of definite integral. I hope this part is clear. And with this, let us end our session over here. Thank you.